Okay, so when we met on Monday, we looked at projectile motion and we had we came up with a working definition of what projectile motion means. It basically means motion in which an object in motion is moving in two different directions at right angles to each other at the same time. So in this case, we were interested in motion happening along the horizontal direction and also motion happening in the vertical direction. So your projectile has to cover ground horizontally. It also has to cover ground or height at the same time. We also realized that along the horizontal, your projectile moves with constant velocity. So the velocity of the projectile in the horizontal direction does not change. So the motion of the projectile along the horizontal direction is constant. However, along the vertical direction, we found out that things were different. The velocity of the projectile kept on changing throughout the whole time the projectile was moving in the vertical direction. So the projectile had to go up. As it was going up, its velocity was reducing until it became zero at maximum height. Then after reaching maximum height, its velocity started increasing as the projectile was coming down. So there were a couple of things we were interested in. For example, we were interested in how much time it takes the projectile to rise from the ground to reach maximum height. That's a physical quantity which we called rise time. We were also interested in the maximum height which was reached by the projectile as it went up. The other thing we're also interested in was how much time the projectile would take to come down from maximum height if the height it went up and the height it fell through were the same. So if that was what you called the fall time. And from other examples we did on Monday, we came up with the same time, which was 39.7 seconds. So in our case, where we had our projectile being fired at 550 meters per second at an angle of 45 degrees, it took 39.7 seconds for our projectile to reach some height, and it went up to a height of 7,720 meters, if I'm not mistaken. Then also when it came down, it took another 39.7 seconds. So that's what we did. So those are the physical quantities we're interested in. The other thing we were interested in was the total amount of time the projectile was in the air. That is what you called the flight time. So in the case of the flight time, we had to add the rise time and the fall time. And in that case, when we did that, we ended up having 39.7 seconds plus 39.7 seconds, which gave us a 79.4 seconds. So that was close to 80 seconds. After finding the flight time, we also found out the velocity with which the projectile would strike the ground in the vertical direction. Again, that came out to be something like 549.7, which was close to just approximately 550. So we discovered that the velocity with which the projectile goes up in the y direction and the velocity with which the projectile strikes the ground was the same. That's what we found out. Okay. The other thing we did was we proceeded from there using the flight time which we had worked out. We proceeded to work out how far along the horizontal direction does the projectile move, which was the range. So in order to work out the range, we used the x component of the velocity, which is how much the launch velocity is along the x direction, multiplied by the flight time. So that's what we did. So when we did that, we found a range which was close to 30,000 kilometers. Okay. Then later on, using the components, because the velocity along the x direction was not changing. Therefore, it meant that the initial velocity and the final velocity were the same along the x direction. So ux, which is the velocity of the projectile along the x direction, initial and the final along the x was the same. Also, we found out when we worked out the strike velocity, say the velocity with which the projectile went up and struck the ground in the vertical direction was the same. So using those components, we worked out what the strike velocity of the projectile was, and we found out that the velocity of the projectile was actually the same as the launch velocity. So that was the long way of doing things. Not long, like long way of doing things, the tedious way of doing things. However, it is possible for us to also come up, as people are studying physics, yes, you can do things that way, which is good, it's fine, okay? But also it's possible for us to consider a special case, and from this special case, we can actually come up with formulas which we can use to find out how much time it will take a projectile to rise to maximum height, what is the maximum height the projectile is going to rise to. So we can come up with formulas which give us these things. And also, what is the amount of time it's going to take the projectile to fall from maximum height. And we can come up with a formula for flight time. We can also come up with a formula for range and a formula for the velocity. These formulas which we come up with, they use only two things. They use the velocity with which the projectile is launched and the angle at which the projectile is launched. So basically, that's all is needed. What is needed is only the velocity with which the projectile goes up and the angle at which the projectile goes up. Okay. So the first thing we're going to do is, of course, recognize that a projectile moves in two different directions at the same time. If you're going to come up with these formulas, there are certain things you're supposed to be aware of. So the first thing is that you have to recognize that these projectiles move in two different directions at the same time. There is horizontal motion, there is vertical motion. The horizontal motion happens with constant velocity. So the velocity doesn't change. It's only the vertical motion which happens with change in velocity. There is acceleration in the vertical. Since there are two different directions in which this thing is going to move, the next thing you're supposed to recognize is that the velocity with which the projectile is being fired from whatever it is it's being fired from is a vector. That's the other thing you're supposed to recognize, that the velocity is a vector. Since we are interested in what's happening along the horizontal and what's happening along the vertical, it becomes very important for you to find out how much is this launch velocity along the horizontal and how much it is along the vertical. So when you're finding out how much a vector, in this case the launch velocity, is along the horizontal axis or the x-axis and how much it is along the vertical axis, what you are doing is you are finding the components of the velocity. So you need to know how much the velocity is along the x-axis, which is the horizontal direction, and how much the velocity is along the y-axis, which is the vertical direction. So we are going to give you a launch velocity, u. From this launch velocity and the angle at which the projectile is launched, you need to find out how much is this u along the x direction and how much is this u along the y direction. So for you to do this, you have to come up with a table like this. So you have your velocity u vector, then you find out how much it is along the x direction. So along the x direction, if you've got a vector u and you've got an angle theta along the x direction, this vector u, the initial launch velocity ux, is going to be equals to the size of the vector u multiplied by the cosine of the angle. So this is how we find the x component of the launch velocity ux. Along the y direction, so the y component uy is going to be equals to u, which is the size of the vector, multiplied by the sine of the angle. So this is how you find out how much the velocity is along the x direction. Ux is equals to u cos theta. Along the y direction, uy, the initial launch velocity is going to be uy is equals to u sine theta. The thing you're supposed to be aware of is that along the x direction, this ux, u cos theta, is going to be constant because there is constant velocity happening there. The velocity does not change. Along the horizontal direction, there is no acceleration, so it's moving with constant velocity. The acceleration is in the y direction because in the y direction, this projectile needs to go to maximum height. As it is going to maximum height, it is going away from the surface of the earth. So the velocity is going to reduce. Since the velocity is going to be reducing, it means that the acceleration has to be negative. And since this thing is moving away from the surface of the earth, we know that acceleration due to gravity is 9.8 meters per second squared. So if you're moving away from the surface of the earth, the acceleration will be minus 9.8. If you come towards the surface of the earth, the acceleration will be plus 9.8. So this part, this table is us recognizing that our launch velocity u is a vector, and we are interested in two different directions. We are interested in the x direction or the horizontal direction. We are also interested in the y direction, which is the vertical direction. So this has been taken care of here. The next thing you do is, after you decompose your launch velocity into ux and uy, the next thing you do is we only look at what's happening in the y direction. We forget about what's happening in the x direction because you can always tell what the velocity in the x direction is. You know what the velocity is. If you know what the velocity is in the x direction, because the velocity is constant, it's not going to change. So you know what the velocity is in the x direction. So we don't have to concentrate too much on it. After a certain amount of time, whether it's 5 seconds or 3 seconds, it's that velocity times the 3 seconds that gives you how much the projectile has moved along the horizontal direction. So it's very, very easy for you to work out how much distance has the projectile moved along the horizontal direction, because the velocity is the same along the horizontal direction. So for the time being, what we are interested in as far as the horizontal direction is concerned is how far the projectile is going to move. That's what we're interested in. We are interested in the flight time. But for us to find the flight time, we need to look at what's happening in the y direction. That's why in step 3, we consider only the motion of the projectile in the vertical direction. In this vertical direction, we want to find the rise time, we want to find the maximum height the projectile is going to reach, we want to find the fall time. Once we find the rise time, the fall time, then we can once we find the rise time, the maximum height the projectile can reach, then the fall time, then we can find the flight time. After finding flight time, we can find the velocity with which the projectile strikes the ground. Then using that information of flight time, we can find out what the range is. So our next step is step 3. We only look at the motion of the projectile in the y direction. We forget a bit about what's happening in the x direction because there is really no change in the x direction. Okay. So as we look at what's happening in the y direction or in the vertical, our interest is to find the time it takes a projectile to reach maximum height, which is the rise time. We are also interested in finding out what is the maximum height reached by the projectile during this rise time, which is S max. Then from the S max, we also want to find out what is the fall time of the projectile, which is the T4. Then using the rise time and the fall time, we want to find what is the flight time. So we know that flight time is just adding the rise time plus a fall time. Then also using the fall time, because this thing is going to be falling from maximum height, we want to find the velocity with which the projectile is going to strike the ground, which is supposed to be Vy here. So that's what the next step is going to be. So how do we get the rise time? Now, for us to get the rise time, we have to recognize that this projectile is going up. Okay, the initial velocity of the projectile in the vertical direction, in the y direction, the initial velocity of the projectile in this table, as you can see, uy is u sine theta. This is the velocity of the projectile in the vertical direction. Okay, so this u sine theta in the vertical direction is not going to stay the same. This velocity will not stay the same because this projectile has to go towards maximum height. As it is going towards maximum height, the velocity of this projectile is going to reduce by 9.8 meters per second every second. So that's telling you the acceleration, that as it is going away from the surface of the earth towards maximum height, like that, in the y direction, maximum height, as it goes towards maximum height like that, its velocity will reduce. Eventually, this velocity will become zero at maximum height. Since the projectile is moving away from the surface of the earth, the acceleration is going to be minus 9.8. As the projectile comes back to the surface of the earth, the acceleration is going to be plus 9.8. So we use this information that the initial velocity of the projectile is u sine theta. As the projectile reaches maximum height, its final velocity is going to be 0 meters per second because it's maximum height, and that the acceleration is minus 9.8 meters per second squared. That. So using that information, we plug that information in here. We work out Vy, the final velocity. So Vy, the velocity of the projectile at maximum height, Vy, in the y direction is equals to uy. The velocity of the projectile in the y direction, initial velocity, plus g, which is the acceleration, multiplied by the rise time. This is what we're interested in. So at maximum height, the velocity of the projectile is going to be 0 meters per second. The initial velocity of the projectile, uy, is u sine theta. Then plus, our g is going to be minus 9.8. So what we do, like what we did previously, is we write this with a negative. So we write it as negative g, since g is 9.8. So since our acceleration is negative 9.8, we write it as negative g, like this. Then rise time, like this. So with this, when you drop your units and you multiply this plus and that negative, you end up with a negative. So when you drop off your units, you end up with 0 equals to u sine theta minus g rise time. So you've got u sine theta minus g rise time. Then you get this minus g rise time. We take it to the other side, you end up with g rise time is equals to u sine theta. Then you divide both sides by g. When you divide both sides by g, you end up with t rise is equals to u sine theta divided by g. So this is the expression. This is the formula you use to find how much time it is going to take your projectile to rise to maximum height. T rise, which is the rise time, is equals to the velocity with which the projectile is launched multiplied by the sine of the angle, then divided by the value of g. So on earth, g is 9.8. Then like that. Is this clear? This expression only requires you to have the velocity with which the projectile is fired and the angle at which the projectile is fired. Mostly, we'll be doing our things on earth, so our g is going to be 9.8. Is this clear? Is this clear on how we have come up with this formula? T rise is equals to u sine theta divided by g. I need confirmation.
Yes, it's clear.
Okay. So now that we have our rise time, which is u sine theta divided by g, we can use this rise time to find the maximum height to which the projectile is going to rise by using this expression. S max, which is the maximum height, is equals to uy, which is the initial velocity in the y direction, multiplied by the rise time plus half g, then t rise squared. So this is expression, the same expression we used on Monday. We are using a similar expression here to find a formula for working out what is the maximum height which you need. Okay, so in this case, again, when it comes to these formulas, this one you have found, you are going to be, as you are writing your exam, which is what I think most of you are going to write physically. So as you write your exam, you are going to be given a sheet of formulas. Okay, so you need to know what you're looking for. You're going to be given a sheet of formulas. It is not a requirement that you know how to derive these formulas, but you need to know which formula you need to use for what. So we are showing you how you come up with these formulas so that you can have all the faith you need in order to use these equations. Okay, so you're not required to know how to come up with these things. We are showing you so that you see how we come up with these things and so that you can use them with confidence. Okay, so here, S max, so the initial velocity in the y direction, that is u sine theta, which that's what you have here. Then t rise, which is what you've just found here, u sine theta divided by g. So here, u sine theta divided by g, then plus half. Now the g here also maximum height. For you to get maximum height, you need to move away from the surface of the earth. So in this case, our g is minus 9.8, so we write it as minus g like this. Then with rise time squared. So rise time is what you found here, u sine theta divided by g, which is here, u sine theta divided by g. Then that rise time, we square it. Okay, so when the rise time is squared like that, now you expand this thing. So you have u multiplied by u here, so you end up with u squared here with sine theta, multiplied by sine theta here, you end up with sine theta squared, then divide by g, then this side also there is this plus and this negative that will give you a minus, then this thing here is going to be expanded, so you end up having u squared sine theta squared divided by g squared like that. So when you do that, the expansion, you end up with this S max is equals to u squared sine squared theta divided by g minus g to then u squared sine squared theta divided by g squared here. So there's a g here on top here. It's going to cancel out one of the g's here. So when one of the g's cancel out, then you multiply this 2 times the remaining g, you end up with 2g here. So you end up having S max is equals to u squared sine squared theta divided by g minus u squared sine squared theta divided by g. So as you can see, there's a g at the bottom here, there's 2g at the bottom here. So the common denominator here is 2g. So g into 2g gives you 2. Then that 2 multiplied by this gives you 2 u squared sine squared theta minus 2g into 2g, that's 1. 1 multiplied by this whole thing is just u squared sine squared theta. So that's what you have here. Now 2 u squared sine squared theta minus u squared sine squared theta is just the same. Basically this expression here is the same as this expression, just that this is twice as much as this. So when you do the subtraction, you end up with u squared sine squared theta divided by 2g. So your S max, your maximum height, S max is equals to u squared sine squared theta divided by 2g. So this is how you find the maximum height which your projectile is going to go to. Again, as you can see, the only requirement here is the velocity with which your projectile lifts, it's fired with, and the angle at which the projectile is being fired. Yes, I can hear a question.
We can't see the screen. I don't know if it's working, but I'm
Oh, it cut? Okay. Let me. Okay, so here, so I think I was here. So we had S max is equals to uy t rise plus half gt squared. So in substitute for uy here from the table, we have u sine theta, then the rise time t rise, that's what you found as u sine theta divided by g, then plus half. The g is acceleration due to gravity. We are going away from the surface of the earth, therefore we write it as minus g. Then inside here we got t rise, which is going to be u squared u sine theta divided by g, the whole thing squared. So this u multiplied by u, and that's to give you u squared sine theta multiplied by sine theta. It gives sine theta squared, then the whole thing divided by g. This plus multiplied by this negative will give you a negative. Then this whole thing squared. When you do that, this is what you end up with. You end up with S max is equal to u squared sine squared theta divided by g minus g over 2 u squared sine squared theta divided by 2g. Then there's a g here multiplied by one of the, so we cancel out with one of the g's at the bottom here, so this g cancels out one of the g's there. Then this 2 multiplied with this g, so you end up with S max is equal to u squared sine squared theta divided by g minus u squared sine squared theta divided by 2g. Again, what I'm saying is, we are not going to ask you to come up with these formulas. We are going to give you these formulas on a formula sheet, but we want you to see how we come up with these formulas so that you understand how the formula came about and under what circumstances you can use these formulas. Because these formulas we're coming up with, they do not work everywhere. Okay? There is a special set of circumstances under which you can use these formulas. And I will explain that very, very soon. Okay. So, the common denominator is, so you've got g this side, you've got 2g. The common denominator is 2g. Then g into 2g is 2. Then we multiply by this, so you end up with 2 u squared sine squared theta minus 2g into 2g is 1, with 1 u squared sine squared theta. Then this and this are the same. So basically it's like 2x minus x. That's give you x. That's basically what, as a person who is studying physics, you're supposed to see. This is like 2x minus x. If 2x minus x is just x. So in this case, our x is this u squared sine squared theta. So you end up having S max is equal to u squared sine squared theta divided by 2g. So here is the maximum height. So the maximum height, as you can see here, depends on u, the velocity. It also depends on the angle. The maximum height does not depend on the mass of the object. Are we clear? There is nowhere in this expression 2 where the maximum height of a projectile depends on the mass. No. The maximum height to which a projectile is going to go to depends on how fast that projectile leaves the ground and at what angle it leaves the ground. Is this clear? So the only thing you need for you to work out maximum height is you need to know what the velocity with which the projectile went up and at what angle it went up. That's what's going to give you the maximum height, not the mass. Okay, so this is how you get the maximum height. Again, we're going to give you this expression. So if you look at this expression, if you see this expression on a sheet of formulas, you should know what this expression does. What normally happens is that even after people are given formulas, most of the time students don't use these formulas because I think they don't understand what the formulas are doing, or where they are supposed to be used for, where they're supposed to be used, or what they're supposed to be used for. But if you understand how a formula comes about, then it saves you the trouble of doing a long calculation. You just plug in the numbers. Whatever we did last week on Monday, how we worked out the maximum height, how we worked out the rise time, you agree with me, it's faster to plug in the numbers in this formula and than do the long calculation. So if you do a long calculation, then it basically shows us that you do not, maybe you don't understand, you don't know about the formulas, about this existence of these formulas, or you don't understand how to use them. Okay. You have a question? Yes.
Why doesn't the object's inertia and gravity have no influence in the maximum height reached by the object?
Because the acceleration is the same. Every object basically of significant weight reduces its velocity by the same amount. The acceleration does not depend on the mass of the object. The acceleration depends on the size of the Earth. It depends on the planet on which you are on, as we are going to show next week. This G is the one which is connected to the mass, but the mass is that of the planet on which the thing is on. So as long as we keep on throwing things up and down on Earth, it doesn't depend on the acceleration does not depend on the mass of the object itself, as we will show next week, or this weekend. Okay, are we clear? So next we move on to how do we find the 4 time. Now we assume, now this is very, very important, we will make the following assumption, which makes these formulas work, and everything else depends on this assumption. We are going to assume that the height to which this projectile rises to, the maximum height to which it goes, is the same as the height through which this projectile is going to fall. So we are assuming that when this projectile goes up, the distance from wherever it was launched to maximum height is the same as the distance from maximum height to the ground. This is a very, very important assumption. If this assumption is not correct, you're given a problem, then this assumption is not there, then you need to do calculations the long way. You need to do the calculation the way we did on Monday. But if you assume that the height to maximum height and the height from maximum height to the ground is the same, then you can use this expression. So you end up with S max, the maximum height through which the projectile is going to fall. So now our projectile is coming from maximum height, and at maximum height in the y direction, when you're at maximum height, the initial velocity uy is equals to 0 meters per second at maximum height. So uy is 0 meters per second. Then from that maximum height, the projectile, so this one uy is 0 meters per second, then the projectile is going to fall. So we want to find out how much time it takes this projectile to fall. Then as it is falling, the velocity of the projectile will not remain the same. Okay, as the projectile is falling, its velocity will not remain the same, but it will increase. So in this case, our g is going to be 9.8 meters per second. So as our projectile is coming down, so multiplied by t4. So what you are looking for here is the t4, the time of fall. So since we have assumed that our projectile is going to fall through the height which is equal to the rise time, and we have an expression of maximum height, and we have an expression of maximum height here, which is u squared sine squared theta divided by g. We put the maximum height on the left here, which is u squared sine squared theta divided by 2g, equals to the initial velocity from maximum height coming down. So initial velocity at maximum height is 0 meters per second, multiplied by the 4 time plus half times g, which is 9.8, multiplied by the 4 times squared. So this multiplied by this gives you 0. So you end up with u squared sine squared theta divided by 2g equals to half g t squared. So this basically gives you this u squared sine squared theta divided by 2g equals to half g t2 squared. So this is supposed to be t4, like this. Okay, there's a half here, there's a 2 at the bottom, there's a 2 at the bottom, so we cancel out the 2 on both sides. When you cancel out the 2's, you end up with u squared sine squared theta divided by g is equals to g t2 g t4 squared. Then we divide both sides by g. When you divide both sides by g, we remain with t4 squared is equals to u squared sine squared theta divided by g squared, like this. Then we take the square root on both sides. When we take the square root on both sides, we end up with so t4 squared square root, then the square root of u squared sine squared theta divided by 2g. So you end up with this. t4 is equals to u sine theta divided by g. So the t4, which is the 4 time, is equals to u sine theta divided by g. If you look at this expression of t4, u sine theta divided by g, this expression of t4 is the same as the expression for the rise time. Rise time is equals to u sine theta divided by g. So this is only possible because we have assumed that the height to which the projectile rises to and the height to which the projectile falls through is the same. Something has happened to my internet. Just a minute. Okay, let's see. Okay, I want to check on the internet. Okay, so this is the only time when the fall time and the rise time are the same. When you assume that the height to which the projectile is going to rise and the height through which it falls are the same. So once you have the fall time, then the next thing you can do is, so here, the rise time and fall time is equal to u sin theta divided by g. So once you have the fall time, the next thing you want to work out is the flight time, Tf, or T flight. Tf is going to be equal to the rise time plus the fall time. So we know that the rise time is u sin theta divided by g plus u sin theta divided by g. So when you add these, you end up with Tf is equal to 2 u sin theta divided by g. So this is what you end up with. Tf is equal to 2 u sin theta divided by g as your flight time. This is how much time the projectile is in the air. This flight time, Tf, if you take this part, u sin theta divided by g, this u sin theta divided by g can either be equals to the rise time or the fall time. So sometimes, if this thing is true, that the height to which the projectile is going to go and come down are the same, you can also give flight time as 2 times the rise time or 2 times the fall time. Why is this important? It is important because sometimes you're given a question, then in that question you are told, oh, this projectile flew for this amount of time. So in that particular question, you are given the flight time, and then you are asked to find maybe with what velocity or at what angle this projectile was fired. Is that clear? So you can be given other pieces of information like flight time. From this flight time, if you conclude that the height to maximum height and the height to and the height from maximum height to the bottom are the same. So in that case, as you can see from this expression, the flight time is twice the rise time or twice the fall time, like that. Okay, so this is how you work out your flight time. Equation 6. Are we clear? Is it clear on how we find the flight time? Okay. Next. Okay. The next thing we want to find out is the velocity with which the projectile is going to strike the ground in the vertical direction. Now, in the vertical direction, this projectile, as it strikes the ground, it is coming from maximum height. At maximum height, the initial velocity was 0 meters per second. then it's striking the ground, and when it's striking the ground, as it moves towards the ground, its velocity increases. So the velocity of the projectile is increasing by 9.8 meters per second. The other thing which is there is we know how much time it's going to take the projectile to fall. T4 is u sin theta divided by g. So using the information, the initial velocity of the projectile at maximum height, then the acceleration, and also the fall time, we can use this equation. V is equals to u plus gt. So in this case, you're looking for Vy. So Vy, which is the final velocity with which the projectile hits the ground in the y direction, Vy is going to be equals to uy plus gt4. Now uy is 0 meters per second because it's coming from maximum height, and at maximum height the velocity is 0 meters per second. And we have an expression for t4. So when you make substitutions, you end up having Vy is equals to 0 meters per second plus g multiplied by u sin theta divided by g. Now here we've got a g on top, the g at the bottom, so these two g's are going to cancel out. When they cancel out, you end up with Vy is equals to 0 plus u sin theta. Then 0 plus u sin theta gives you Vy is equals to u sin theta here. This Vy equals to u sin theta is the same as the velocity of the projectile when it went up. It's the same as this one, uy. Uy is u sin theta. Uy is u sin theta, and Vy is u sin theta also. Vy is u sin theta here also. So apart from the flight time, the rise time being equal to the fall time, here we have evidence also that the velocity with which the projectile will hit the ground in the y direction is the same as the velocity with which the projectile went up, and that is equals to u sin theta. Is this clear? Is this clear? Okay. Next is, now we want to consider what's going to happen, how much distance, now that we have got the flight time. Okay, now that we have got flight time here, now that we have got everything we need, we have got the rise time, we have got the S-max, we have got the fall time, we have got flight time, then we know the strike velocity in the y direction. We want to find out what is the distance the projectile is going to move in the horizontal range, in the horizontal direction, which is what is called the range. Now for you to find range, you need to multiply the velocity of the projectile in the x direction, which is this one, ux is equal to u cos theta multiplied by the flight time. That's how you find the range. And that's what you're trying to do here. The range r is equals to ux multiplied by tf, which is flight time. In our case, ux is u cos theta multiplied by the flight time, which is 2 u sin theta divided by g. So if you carry out this multiplication, you've got u here multiplied by that u, then you've got a cos theta here multiplied by sin theta there. So you end up with, and there's a 2 there, you end up with 2 u squared cos theta sin theta divided by g. Then this u squared divided by g, we pull it out, we factor it out, so you end up with u squared on top, then g at the bottom. Then you remain with, inside you remain with these 2 cos theta sin theta. So this is an angle. Okay. Now we need to find this. Up so far this is correct, but we need to find an easier expression which we can replace with this. So we go to mathematics, people, friends in mathematics, and they have a lot of things which you can use. One of them is this identity here. It's a compound angle. So this one says sine A plus B is equals to sine A cos B, then plus sine B cos A. So this is an identity which you can find. Now, since we are physics people, the next thing we do is we make A equals to B. So if A is equals to B here, so A, that is A, then this B, if it becomes A, we end up with sine A plus A, which is going to be equals to sine 2A. This will give us sine A cos A, then sine A cos A again. So we end up with 2 sine A cos A. Now when you look at this, 2 sine A cos A, 2 sine A cos A is similar to this. 2 cos theta sine theta. Very, very similar. The only difference there is the theta. So if we change for A, instead of A, we write theta. So what we end up with, you're going to end up with 2 sine theta cos theta. So this 2 sine theta cos theta is going to be equal to this. 2 is going to be equal to sine 2 theta, sine 2A, which is going to be equal to sine 2 theta. So when we change for A, if we substitute A for theta, so we end up with sine 2 theta is equals to 2 sine theta cos theta. So now we can replace this 2 sine theta cos theta, which is here. We can replace it with a much more simpler expression, which is equals to sine 2 theta. So we end up with range R is equals to U squared divided by G sine 2 theta. And that gives you the range is equals to U squared sine 2 theta divided by G. So this is the expression for the range. This is how you get the range. How far your projectile is going to move, again, depends on the velocity with which it's launched and the angle at which it's launched. Now, if you are interested, as we are going to be interested in, if you are interested in something called maximum range, if you are interested in something called maximum range, then this angle, this sine 2 theta, this 2 theta needs to be equal to 90 degrees. Because when 2 theta is equal to 90 degrees, then sine theta is going to be equal to 1. And theta only has a maximum value of 1. So theta has got a maximum value of 1. The rest of the time, the value theta has is less than 1. So if we set this 2 theta to be equals to 90 degrees, then the angle theta is going to be equals to 45. So that means that if you are interested in your projectile covering maximum distance, you need to fire your projectile at an angle of 45 degrees. So when the angle is 45 degrees, then this sine 2 theta is going to be equals to 1. So what you end up with is going to be R max, which is maximum range, is equals to U squared divided by G. Here. This is how you get your maximum range. Your maximum range is going to be equals to U squared divided by G. So the other thing you notice is the following. If you are given a maximum range, say this is a maximum range, from the maximum range you can directly find out what is U, because just make U the subject of the formula. So you end up having range R max multiplied by G, then you got U squared this side, then take the square root on both sides, and that should give you your U. So you should be able to play around with these things so that you find whatever it is you're looking for. Are we clear? Are we clear on how we find the range and also on how we find the maximum range? Are we clear? I need confirmation that people have understood before we move forward. Okay. If there are no questions, then we'll proceed. No, there's nothing to proceed to. So we have come to the end here. Of course, the velocity of the strike velocity is the same as the launch velocity. Are there any questions? If there are no questions, we have come to the end of this class. So the only thing I need to do now is I need to schedule a class for Saturday. Okay, I need to schedule a class for Saturday. Then once I schedule the class for Saturday, then we're good to go. All right. So we have come to the end. I'll stop the recording.